We only have two left. 29 and 31. All right, so the only issue I'd run into here, division by 0, would occur if e to the x minus 1 was 0. But that happens when e to the x is equal to 1. And you can tell here if I raise e to the 0, I get 1. So if x is 0, I have a problem. And 0 is within my interval. 0 is in here. So I'm going to have something happening there. It's not good. So I'm going to have to approach it from both sides. So I have to break this up into two integrals. So it'll be integral from -1 to 0 first. And then the integral from 0 to 1. And then I'll have to put the limits in there. But before I do that, let me integrate this. Basic u sub. And then that becomes integral 1 over u du, which is natural log of u, which is natural log of e to the x. But that's just x. So that's kind of weird that we just get x. So you might be saying to yourself, well, how in the world, oh wait, sorry, e to the x minus 1, that didn't seem right. Okay, e to the x minus 1. U is e to the x minus 1, not e to the x. So I can't simplify this at all. All right, so we got limit t goes to 0, and I'm on this integral, so I'm over here. I'm going to be approaching 0 from the left of the antiderivative of this, which is natural log, absolute value of e to the x minus 1, evaluated from -1 to t. And then I set up this integral, plus limit, this time t is approaching 0 from the right side, because I'm on this one, of the antiderivative of that, which is natural log of e to the x minus 1, evaluated from 0 to 1, but 0 is the t. Now I'm just going to write out break it up into the two pieces, each one of those. So this first one is limit t approaches 0 from the left of, okay, plug t in first, natural log, absolute value of e to the t minus 1, and then minus, now plug in -1, so e to the -1 minus 1, so natural log of e to the -1 minus 1, that's just some number, I don't know what it is. And then we set up the next one, which will be plus limit as t approaches 0 from the right of, again, two things. First we plug in 1, natural log e to the 1 minus 1, and then we get minus, plug in t, natural log e to the t minus 1, and then close it off. All right, let's let t go to 0. T goes to 0 here, e to the 0 is going to be 1, 1 minus 1 is 0, natural log of 0 is undefined, but really we're saying what's the behavior of natural log as you approach 0. So if you're on the natural log function, as you head towards 0, the natural log function dips down to -infinity. So this whole expression is going to -infinity. And at that point, we can stop because that means the entire integral diverges. So you could check. This is just a number. This one's a number, but then again, this one goes to -infinity. So you have a problem. So diverges. Last one, I think. Integral 0 to 2, oh no. Integral 0 to 2 z squared natural log z dz. I'm going to take care of the integral first, the integration. So integral z squared natural log z dz. I'm going to use integration by parts. U is going to be the natural log of z. dv is going to be z squared dz. The antiderivative here is 1/3 z cubed. The derivative here is 1 over z dz. And so this integral becomes ultraviolet, this times this, 1/3 z cubed times natural log z minus this times this. The 1/3 comes out. Integral z cubed and then 1 over z multiplied to give you just z squared dz. And then I can integrate that. That's going to give me another 1/3 z cubed times that. So 1/3 z squared natural log z minus 1/9 z cubed. So now let's talk about where this is having some issues. The only problem I have, I can plug in any number here, squared, that's not a problem, but the natural log function is not defined at 0, and 0 is part of my interval. So my interval is 0 to 2. I have to approach 0 from the left-hand, or from the right-hand side. So I'm going to do a limit. T is going to approach 0 from the right-hand side of the antiderivative of this, evaluated here and here. So antiderivative is 1/3 z squared natural log z minus 1/9 z cubed, evaluated. The bottom one was 0, but that's my t, up to 2. So this is equal to t goes to 0 from the right, and now I have two pieces. First we'll plug in 2. So 2 squared is 4, so 4/3 natural log 2 minus, see 2 cubed is 8, so 8/9. And that's just a number, something. Minus, now we plug t into this, and we get 1/3 t squared natural log t minus 1/9 t cubed. All right, now, if I let t go to 0, that's 0, and this is natural log of 0, and then that's 0, but that's 0, so I don't need to worry about that. But this one right here, I need to investigate, because I get a 0 times, and we just said a second ago that as natural log heads towards 0, it goes to -infinity. So we have that special case. So let's take a look at how we can deal with that. Limit t goes to 0 from the right of t squared times natural log t. I'm going to rewrite that as natural log t over t to the -2. So I drop the t squared down. And remember that that's really the same as natural log t over 1 over t squared. And now, as t goes to 0, we said the top goes to -infinity. And the bottom, as t goes to 0, you get a fixed number over 0. That goes to infinity also. So you get infinity over infinity. So I can use L'Hopital's rule on this. Derivative of the top is 1 over t. Derivative of the bottom is -2t to the -3. So this is the same as limit t goes to 0 from the right, 1 over t over -2 over t cubed. And then when you flip that up, flip it, and then you can reduce a power. You get limit t goes to 0 from the right. What do we have here? T squared on top over -2 on the bottom. Now if t goes to 0, this just goes to 0. that whole thing goes to 0. So if this whole thing goes to 0 times 1/3, that goes to 0. We already said that went to 0. And then over here, this would be our answer. So let me check that. That doesn't look familiar. Eight thirds natural log 2 minus 8/9. 8/3 natural log 2. Off on something here. Oh, ultraviolet. Oops. My bad. Oh, that changes everything. Shit. I'll try and fix it. I don't want to fix the video. This should have been a cubed. It was right in my integration by parts table. This was right. Ultraviolet should have been a cubed here. That would have made, when we plugged in 2, this would have been 8/3. So 2 goes into here, we get 8/3, and then same, this is still okay. But then over here, this should have been a 3. Still goes to 0 in negative infinity. Over here, this would have been a -3. This would have been a 3. Same thing happens. This derivative would have been a little different. 3 here, -4 here. And then this would have changed. Nothing's going to change in the answer. It's just that that little piece was off. So this is going to be -3 over t to the 4th. Flip it, t to the 4th over -3. So this is limit t goes to 0 from the right of t cubed over -3. And as t goes to 0, that goes to 0. The whole thing goes to 0. And so this whole thing still goes to 0. So we get the same exact result, except that this should have been 8/3 instead of the 4/3. So that's it for that.